Welcome, everybody. I'm going to talk today about how we do the physical and visual stream assessment. I'll go through all the details of the data sheet, and then the second half of the presentation will be about the rapid bioassessment protocol. I'll explain what that is and how we answer each of the 10 questions on that rubric. Just going to briefly go over safety. So we want you to always be safe, of course. A wadable stream is safe to enter and stand in. The water level should be no more than thigh or waist high, but it could be less than that if you are shorter or if the flow is fast. If it's pushing you over, then it's too fast, and you might not be safe to be in that stream. So page 1 of the data sheet. This is what it looks like overall, and then I'm going to zoom in on each section. Some of them are self-explanatory: the date, the time that you're doing your assessment, the organization that you're with. Investigators is your names. So we want you to have your first and last name or first initial and last name because first names are so common that it could be confusing if you only use first names. Site ID and site location, those will be given to you by your project leader. Approximate reach length. So this is aim for 100 meters. There are some situations where maybe you're not able to do 100 meters, and you would write that in here and what length you were able to assess. It should be close to 100 meters, if not 100 meters. You'll take an air temperature reading in degrees Celsius and water temperature in degrees Celsius. You'll record the current weather conditions. So, just obvious, is it clear, cloudy, is it raining? Hopefully you're not doing any assessments in heavy rain. This is just a lot less comfortable for you. And also when the substrate is stirred up and the water is turbid, it's much more difficult to get a good look at what the substrate looks like and to be comfortable with walking in the stream, and also just being able to do a good job of assessing the stream. So, and that's the same reason why we ask the question on the right, which is how long has it been since the last rain? If it's a little bit of rain, that, go ahead and check that box. But if it's a lot of rain and it's causing the stream to be too high and maybe unsafe or very turbid to where you can't see where you're putting your feet, then those would be good times to reschedule and not do an assessment that day. Also, we recommend that you not do an assessment if it's very cold. It's, again, uncomfortable for you and possibly unsafe. Going down to this next section of the data sheet, you will take a representative width of the stream. So we're not trying to do like a engineering survey or anything. We're just trying to get a general description of what this stream is like. So you'll pick what looks like basically an average width, a spot that has the average width for your 100 meters, and you'll take a measurement there. You'll indicate the units. The preferred units are meters, but make sure that you write, if it's not either way, write what meters you've used. Along that width, you will also take 5 measurements of the depth. And I will kind of demonstrate what that would look like. So the width is the width of the actual water. So that's the picture on the left. And the picture on the right represents somebody taking some measurements along that same location where you're measuring the width. You're also measuring the depth. One in the middle, one at each, going towards each direction about halfway, and then one on each side, maybe 6 inches or so from the edge. That'll give a good representation of what the stream looks like. And then for stream velocity, you'll mark off a 3-meter or a 10-foot length. That will depend on if your tape measure does meters or feet at a representative section of your stream. So if your stream is all slow, then you'll pick a slow section. If it's all fast, you'll pick a fast section. If it's in between, try to pick an in-between section. You'll float your, you'll measure that out. You'll have one person upstream and the other person in the downstream direction. You'll float the tennis ball or a duck, whichever one you have, along the transect. You'll time how long it takes. You'll repeat this 4 or 5 times. I forget if the data sheet actually has 4 times on the data sheet. You'll record those and you'll take an average. You don't have to do the math in the field. It's probably easier if you don't. Then in the third section of the data sheet, you'll answer a number of questions about what the stream looks like. So is the stream flow slow? So is it barely moving or not at all? Is it moderate, clearly moving, but the surface is flat? Or is it swift? It's clearly moving and the surface is disturbed, like riffly. You'll answer whether there is an odor to the water. And this will be, if it's normal, you're probably not going to, notice anything. Just be like, oh, it just smells like the outdoors. Anaerobic, sulfuric, sewage, petroleum, or other. I don't know what those others might be, but maybe, I don't know, maybe if there's detergent that has like a perfuming smell, maybe that would be under other. For turbidity, so that's how easy it is to see through the water. Is it clear? Is it slightly turbid? Is it turbid or muddy? Is it milky or green pea soup? And I have slides that show examples of these. For the surface coating, is there none, foam, scum, or paint streaks? And what is the color of the water? I already went through what does the stream look like as far as stream flow and odor. And we don't, this is a piece of equipment is called a Secchi disc, and we don't need to use those. Our streams that we're monitoring are usually fairly shallow, and we don't need to use a Secchi disc for this. It's just a good way to illustrate what it would look like. Can you see the bottom very clearly? Is the water clear? Is it slightly turbid? Or maybe if you can't see it at all, it is very turbid, like in this example. Or is it sort of a milky turbid? You could check off that box. Or does it look like pea soup? Now, in this situation, it could possibly be a harmful algal bloom. So this would be a situation where you might decide that you would not want to monitor that stream that day. It is very more rare for there to be a harmful algal bloom in a flowing stream, but it's not impossible. So a surface coating, this slide illustrates like an oily coating, which can be natural. Usually we say if it can be, if you like poke a stick at it and it kind of breaks up, that's probably a natural oil. If it kind of swirls around and it's kind of rainbowy color, that's probably a petroleum kind of an oil. Is there a scum? So obviously that's not a technical term, but you'll look at the stream and you'll be like, ew. But in this case, it's when you touch it, it's actually more cottony, but you would describe that as the choice that says scum. Sometimes there's foam. And this again can be natural or from man-made. In this case, you can see that some of the foam is looking kind of brownish. So natural foam can be from the aeration of the water along with natural plant oils and creating a foam. But it can also be from things that we put into the environment, like from washing our cars or things like that. Another choice for surface coating is floating duckweed. So duckweed is a small plant. When you look very closely, you can pick it up and it's little leaves with the tiny little root on it. So that's duckweed. This surface coating is actually a harmful algal bloom, and it sometimes looks like paint streaks. Green and blue-green algae can look like this. And in this case, you do not want to be monitoring the stream if it looks like this. But you can finish that part of your data sheet and report it. Watercolor, typically it's clear, but in some cases, maybe there's a color, maybe it's green or brownish, especially if you're in South Jersey and the Pinelands. Like the picture on the left shows sort of a tea color to the water, and that's natural for that area. And so sometimes color can be natural, but you'll record that on the sheet. In the next section, I'm going to talk about stream morphology, woody debris, macroinvertebrate habitat types, and the benthic substrate. So we want to be looking at where are the places where the macroinvertebrates are going to be living in this stream. So this is the same little video that Erin showed yesterday, illustrating stream morphology, showing how there's a run and a pool and a riffle in this photo. Woody debris. So woody debris is something that some macroinvertebrates really like to live in, that type of a habitat. This photo would illustrate where you would check off rare, because I'm not seeing a whole lot of wood in this picture. Maybe a little bit, maybe a piece over here on the side. In this picture, and again, we're looking at our whole 100 meters, not just one little picture that I can illustrate on the slide. But this picture shows some roots that are in the stream, and I would call this moderate. This stream shows an abundant amount of woody debris. You can see a bunch of logs and branches and things that had fallen into the stream, some roots, some trees that maybe their roots are hanging down in the stream over here. And remember yesterday, Erin was talking about the different habitats that macroinvertebrates like to live in. So in this question on your data sheet, you're just going to check off the ones that are present. So are there riffles and cobble? Is there wood and submerged logs? Are there leaf packs? Excuse me. Is there aquatic vegetation? And aquatic vegetation is vegetation that's in the water, and I'll be showing some pictures of those in later slides. But we're not talking about vegetation that's growing on an island or on the stream banks. We're talking about what's in the stream. Is there overhanging vegetation that's like actually hanging down into the water? Are there undercut banks, gravel, sand, or other? In this section of the data sheet, this one can be a little bit challenging at first, because we want you to decide on a percent for each of these different types of substrate. And it goes by size. So clay and silt is very small, less than a millimeter in size. Sand is about 1 to 2 millimeters. You can feel that it's gritty. Gravel is about 0.1 to 2.5 inches. Cobble is about 2.5 inches to 10 inches. So say the size of a tennis ball up to maybe a basketball. A boulder is over 10 inches, so like over the size of a basketball. And bedrock is when the rocks are unbroken. And we will see some bedrock definitely at Nishosaquit Creek when we're out in the stream on Saturday. And you don't have to be worried about getting the percentage exactly right. We do want you to make sure that it adds up to 100% because that makes sense. And especially to show what things are there and which things are not there, and in what order they're present. So you can kind of talk it over with your partner and come up with percentages so that it adds up to 100% and is in the order that they are present. In this section of the data sheet, we're going to talk about the types of aquatic vegetation and algae, what kind of vegetation is on the banks, and how much tree canopy there is. So in our data sheet, we have the choices of rooted emergent vegetation, free floating, rooted floating, and rooted submergent. And I'm going to show examples of each of these. So this plant is a rooted emergent plant. So the roots are in the water down into the substrate of the stream, and then they're emerging out of the water. So that's what it means by rooted emergent. This slide shows rooted submergent vegetation. So it's rooted into the bottom of the stream, but it doesn't grow upwards like with strong stems out of the water. Now, if the water is very low that day compared to when the algae or plant was growing, it might stick out a little bit, but you'd probably be able to tell that its normal amount of growth is that it would be under the water. Rooted floating vegetation is things like water lilies. So they are rooted in the bottom of the stream, and they're floating. The leaves are floating on top rather than being underwater or sticking up into the air. Free floating are like the duckweed that I mentioned earlier, and the line drawing in the middle shows what they look like if you look very close. So the leaves are very tiny, but they're little leaves, and they're not attached down into the substrate. They're just floating around and with little leaves and a tiny root that just hangs down into the water. That's free floating. So in the box that talks about algae, you'll be saying whether there's periphyton on the rocks. This is very common. Sometimes we don't realize that that's an actual algae that's growing, but it is food for some of the macroinvertebrates and habitat. So we want to say whether it is there and whether it is abundant or not. Often we notice it because it makes the rocks very slippery. There could also be filamentous algae. These form long visible chains, threads, or filaments. They might look kind of slimy, but when you touch them, they often feel kind of stringy or cottony. And they kind of form a mat, or I like to say they kind of feel like wet wool if you actually take them out of the water. You're like, oh, this doesn't really feel slimy at all. But it can float on the top, and in contrast to the harmful algal blooms that I was talking about earlier, that will not look like this at all. The harmful algal blooms are single-celled, and you won't see threads or woolliness. So to reinforce that thought, on the left is scum or algae that holds together if you were to poke it with a stick, and on the right are some examples of harmful algal blooms or from cyanobacteria. And if you were to poke it, it would stir around, but you wouldn't be able to pick anything up. It would just be in the water. And if you do think something is a harmful algal bloom, again, you should report that, and DEP can follow up to see if it is or not. The next question is about bank vegetation. So this illustration shows the trees, the shorter woody growth like shrubs, and non-woody plants like grasses, flowers, things like that. And ideally, you will have a variety of all three types. For the tree canopy, you're going to be looking up from the middle of the stream, or imagining what it looks like from the middle of the stream, and how much of the water gets shaded by the tree canopy. And the illustration is just kind of gives you an idea of what that would look like if it was, 10, 20, 30%. And then you will pick the one that is most representative, but remember, thinking about the whole 100 meters. How much shade is this stream getting? Here's an example of one that's open. I don't see any trees shading this stream. Partly open, I see a good amount of sky, but also a good amount of shade. And then mostly closed or closed. This one's nice and shady, keeps the water much cooler. Now we're already jumping to page 2 on the back of the data sheet. So this is what the full page looks like, and I'm going to be going into each part separately. So at the top, we want you to check off what land uses are within about a 1/4 mile radius of your site. So this is a little beyond what you can see from where you are when you're actually at the site. So it's a good idea to look at your site on online mapping to get an idea of what's around around your site. You'll record any structures, any litter, and wildlife observations. So here's some examples of land use, such as commercial, industrial, farmland, maybe preserved open space. Here's some examples of structures, and we're just talking about the structures that are within your 100 meters. So often there's a bridge, because often we choose our sites where there is a road crossing, because that's the most convenient. There at the top left is a culvert. The top right is a dam. Now, we're not going to have any sites that include the dam, and preferably we're not doing a site that is any closer than 500 feet from a dam. That way you're avoiding any possible influence from the dam and getting a better picture of the health of the stream. At the bottom left, there's just like I don't know, the remains of something that people built, a little, maybe a weir. But that's still somewhat affecting the stream as well. So you would record that on your data sheet. You could record if you have any observations of wildlife or livestock, evidence of beavers in the area. Geese or cows could be sources of nutrients, let's call them. And is there, how much litter is present? So this is a good place to record if there is a need to come back and maybe do a cleanup in that location. The site sketch, I don't know that I've ever met anybody who enjoys when they get to the site sketch section of the data sheet. It doesn't have to be an art project. Basically, we want to have a recording of where you entered the stream and kind of some important characteristics of that stream in that location. So when you draw your stream, however you draw it on the picture, which way is the water flowing? Where did you enter the stream? Are there buildings around? Where are the riffles or pools or the in-stream structures that we talked about? This will give like a heads up to the people who are maybe the next time, whether it's yourself and you just want a reminder of where you entered the stream last time, or the next person who's going to be monitoring there can get a good idea of what the site looks like, where you parked. That can be helpful as well. And I don't think I've ever seen a site sketch be this detailed or this neat and artistic, but it gives some examples of things that you would want to include. We are down to the section where it asks about which region are you assessing? Are you assessing high gradient or low gradient? And this is determined by the physiographic province of where your site is. So it's not going by whether there's actual riffles or not. Sometimes in the northern part of the state, your site might be in a place where if you were to describe it, you wouldn't say, oh, there's a high gradient here, but you were in the high gradient section of the state. For the people who are on Stream School today, the answers for this section are always going to be the same. I'm not sure if your project manager might not give you the wrong answers. Maybe they'll just edit the data sheet so that you only have the right answer available. But the sample equipment that you're going to be using is a DNet. The preservation method is that you are not going to preserve the samples. You're going to be identifying them in the field. So you would check off where it says none, Tier 3.1 field identification. And then on the right, where it says the form attached, the form that you're going to be attaching is the Tier 3.1 macroinvertebrate tally sheet. And Erin showed you that in one of her slides yesterday, and she'll go over that in more detail. So this is called the Rapid Bioassessment Protocol. It was developed by EPA. And at first, it's not going to seem rapid at all. But once you get the hang of it, it will be. There are different data sheets for low gradient versus high gradient. Some of the questions are very similar and some are a little different. I think everybody on the call tonight is working in high gradient streams. We want you to walk the whole 100 meters first and then fill in the sheet. This way, you're keeping the whole 100 meters in mind. Otherwise, you might have a tendency to look at just the section that's right in front of you, and that won't be representative of the whole 100 meters. So this is what the sheets look like all together, and then I'll go through each question close. Again, to review, I just said high gradient streams have some elevation above sea level, and this includes the highlands and the Piedmont region of the state. And the low gradient streams include the coastal plain region and the Pinelands. Here's some photos that illustrate what a high gradient stream might look like. Sometimes we call them rocky bottoms because they usually do have a rocky bottom. And I'm not going to read through all these questions, but these are the 10 questions that are being answered for the high gradient rapid bioseismic protocol. And just real quickly, so you know what this is in contrast to the muddy bottom or low gradient. They're not always muddy, sometimes they're sandy, but they're usually not very rocky at all because we're talking about the coastal plain. They're going to look more like this. They're not going to have those boulders sticking out like you would probably see in a high gradient stream. And there are 10 questions. Most of them are the same, but there's a few that are different from high gradient. So the first question on the data sheet is asking about epifaunal substrate or available cover. It refers to the stable habitat that's present in the stream where macroinvertebrates can live, such as rocks, sticks, roots, and organic matter. So it's important to read the actual words of the question because that will help you decide on what number to choose. Each question is worth between 0 and 20 points, 0 being the worst stream, and up to 20 being perfect. So we don't very often give a 20, but it's just for one question. So it is possible sometimes to be giving a 20. I usually start with the condition category that I think is probably applicable to that stream. So let's just give it the benefit of the doubt and start out with reading the optimal description. So it's saying that 70% of the substrate is favorable for epifaunal colonization, including submerged logs, undercut banks, cobble, and other stable habitat. We're not talking about woody debris that's just floating past, because that doesn't have a chance for macroinvertebrates to live on it. Okay, I'm not going to go into detail on the low gradient, but so for suboptimal, that mix of stable habitats would only be 40 to 70%. In marginal would be 20 to 40%, and in poor would be less than 20%. So unstable habitat would be things like just like mud or silt. So question 2 is embeddedness. This talks about the degree to which fine sediments surround the coarse substrates. So how those cobbles and boulders are embedded into the stream. Aaron likes to say like it's peanut butter around them. Like, wait, how hard it is to pick up that rock? Are you disturbing a lot of sediment as you're picking it up? If it's an optimal stream, those rocks are only going to be surrounded by 0 to 25% of fine sediment. So it's going to have lots of places for macroinvertebrates to live. It's there's little nooks and crannies for them to live. And if there's less, 25 to 50%, it would be in suboptimal range. marginal would be 50 to 75% covered by fine sediment. And if it's more than 75%, that would be poor. Here's an illustration of what that might look like. So if it's 0 to 25%, you're seeing like the rocks and cobbles. As you get more, you can see that there's just like silt in between instead of being able to see the outlines of the rocks. I'm going to skip over the low gradient section. So the next question asks about velocity and depth regimes. So there are 4 choices of velocity depth regimes. There's slow deep, slow shallow, fast deep, and fast shallow. So you can understand why it was important to look at the whole 100-meter stretch, because each one of these might be in different locations of the stream. You might not be able to tell how deep a spot is or shallow until you actually walk in it. So slow is less than 0.3 meters per second. I know that's hard to visualize, but basically it's not disturbed on the top. It's moving the water is moving very slowly. Deep is not particularly deep. It's over half a meter, so it's more like knee deep. So it doesn't have to be very deep, but if you're a small macroinvertebrate, that seems deep. If you have all that diversity, if you have all 4 of those, then you would be up in the optimal section. But if you only have 3 of the 4, you would be down in the suboptimal. And if the fast shallow is missing, you would score it with a lower score, maybe the 11 or 12. But if you do have fast shallow and something else is missing, then you could give it a better score, like 14 or 15. If you only have 2 of the 4 habitat regimes present, then you would be down in the marginal section. But if you only had 1 type of habitat, you'd be in the poor section. For sediment deposition for the next question, in the optimal situation, there's little or no enlargement of islands or point bars, and less than 5% of the bottom is affected by sediment deposition. It's the amount of fine materials that are present and the presence of sandbars. So this is always a little bit of, awkward to answer, because you're like, well, I've never been here before. I don't know if this is a new sandbar. I don't know if there's more gravel deposited here than there was before. But basically, you will be able to tell if there is a sandbar and if there's gravel deposition. And if that is more than 5%, then you would not be in the optimal range. If it's between 5 and 30%, you would be in the suboptimal range. If you have 30 to 50% is deposition, then you would be in marginal, and greater than 50%, you would be in the poor range of the condition. So I hope that this photo gives you a little better idea. The words don't always convey the idea of what this would look like. So you can see, especially in the bottom left and sort of in the middle left, there's a lot of gravel and sediment where the water probably used to be. And there's just been this deposition from upstream erosion that is impeding the flow of the stream. And so this one would, depending on how extensive this is, as a portion of your 100 meters, is how you would score it, but it definitely would not be in the optimal range. Here's another example. This is like a point bar where there's sediments and even like larger rocks that got eroded from upstream, and they're depositing in the middle here. The next question is called channel flow status. It refers to the amount of water filling the channel. So in an optimal situation, the water reaches the base of both of the lower banks and a minimal amount of the channel substrate is exposed. So this is a little bit similar to the previous one, where if there's a lot of gravel exposed on the sides, it's not going to be in the optimal category. If the water fills 75%, then you're in the suboptimal category. If the water only fills 25 to 75%, you're in marginal. If there's very little water in the channel, mostly as standing pools, you'd be in the poor situation. So you can see how this, the answer to this question is going to depend a lot on exactly when you're visiting the stream. If it is a drought year and you're doing your assessment in the middle of the summer, in the middle of the drought, you're going to be giving this stream a lower score than if you had visited it in the spring. And that's normal, that happens. The condition is going to vary throughout the year. And this photo illustrates what that would look like. So the width of the stream where the water normally would be is the yellow line. So you can see where the kind of where the roots go down. You can see that at some times of the year that's where the water is, but in the time that this photo was taken, the water is only where the red line is. So you can see that it's maybe only 50% at this location. The next question is about channel alteration. It asks, has the path of the stream bed been altered in any way, and was it recent? This is, maybe an awkward question again to answer because you don't know, you weren't there when it happened. Maybe it was a long time ago. But if you can't see evidence of channelization or dredging, and if the stream has a normal pattern, and again, what's normal? Well, if it's very, very straight, then that's not terribly normal. So most streams are going to naturally have at least a little bit of a curve to them. So if you don't see anything and the stream looks pretty normal in its channel, then you could be in the optimal situation. But if there's some channelization present, but maybe it happened a while ago, you could be in the suboptimal category. This could be something like you can see that some rocks were placed on the stream bank to stabilize it. So you can tell that people put that there, but otherwise it looks fairly natural. Maybe you're in this suboptimal category. If the channelization is extensive, and remember you're looking at your 100 meters, you can see it's shored up with different structures that maybe affect 40 to 80% of the stream reach. And maybe it's very straight, then you would be in the marginal category. If the banks are shored with gabion or cement for over 80% of the stream reach, and it's greatly altered, then you're in the poor category. Here's an example of a channel that is highly altered and would definitely be in the poor category. I wouldn't even recommend doing a stream assessment here. For one thing, there's fences that prevent you from getting into that water. And for another thing, there's no natural habitats for macroinvertebrates to live in, but it's just showing this slide so you can see the extreme alteration. In this picture, on the left, it's very altered, but on the right, it looks natural. So you would be, somewhere in the middle, especially depending on how much is the entire left side of the bank, like what you see in the front here, or maybe it's just maybe 25% of it or something like that. So you would take that into account when you choose a number. Here's a location where you can see that those rocks were put there by people. They look stacked. They look like they were put there to reduce erosion, but they're kind of blending in. So you wouldn't give it a perfect score, but you wouldn't rate it as low as the previous two slides. And the side that's closest to us, that looks like it's pretty natural. The next question is called frequency of riffles. So riffles have the benefit of adding oxygen to the water. So that's really great for aquatic life, to have lots of oxygen in the water. And so we want to know how many riffles there are based on the width of the stream. If it's optimal, the occurrence of riffles is relatively frequent, with a ratio of the distance between riffles divided by width of the stream is greater than 7:1. And I know it says less than, but I think that we need to fix that. So if it's completely riffles, that's great. But you also want to see that there is some variety. So you want to see some boulders that are sticking out and other places that are a little different, so that there's a variety of habitats available. I know it gets a little that description is kind of wonky, asking you to do all this math or anything, but so I provided an example at the bottom. If the stream is 10 meters wide, the optimal would have a distance between riffles of 50 to 70 meters. So you're going to want to see at least two riffles within that stream length. But if you are seeing only one riffle, maybe the next riffle is, you can see it in the distance, maybe it's 150 meters between, then you would be in the suboptimal category. If you could only see riffles every 150 to 250 meters, that would be marginal. And then poor would be if there's even less than that, maybe no riffles at all. This one's for low gradient. Okay, so bank stability is scored separately for left bank and right bank. So the total for this question is going to be between 0 and 20, just like the other questions, but you're going to look at each bank separately and give a score between 0 and 10 for each bank. So bank stability refers to the severity of erosion occurring on the banks of a stream. So you're not looking very far from the water. You're just looking at the stream banks, maybe a few meters. And if it's optimal, the banks are going to look stable. Evidence of erosion or bank failure is absent or minimal, and there's little potential for future problems, with less than 5% of the bank affected. And as you go to suboptimal, there's maybe some erosion, 5 to 30% of the bank is affected by erosion. If you're in the marginal category, between 30 and 60% of the bank has erosion, especially during floods. And if it's poor, it's unstable with many eroded areas raw, or like you can see the dirt, you can see where the erosion has happened. Maybe it's very recent. You might see sloughing. I have a picture of that to describe what that looks like. And affecting between 60 and 100% of the bank. So in this picture, we're looking at the two separate banks, and they both look very well covered by vegetation, and I'm not seeing any erosion. So I would score this section extremely well. This one, I'm seeing a little bit more erosion down towards the water. This one, I'm seeing some very severe erosion. Those roots, those tree roots, used to be in the ground, but that ground has now been eroded away, and there's bare ground there. So this one I would score, much lower. And here's some sloughing. Sloughing means like that water, that the stream bank has been so eroded by the water that it's just falling down into the stream. It's sloughing into the stream. So that's what that would look like. And with the extreme storms that we've had in recent years, I unfortunately see this pretty commonly. Another illustration of that, you can see those tree roots hanging down there. Looks like the trees are about to fall in. Looks like the ground is about to slough off down into the stream. So I would score this one, much lower. Okay, we're up to our last question. This one also gets scored separately for each bank, and it's asking for you to describe the bank vegetative protection. So how much of the stream bank is in the immediate riparian zone is covered in vegetation? If more than 90% of the stream bank is covered with native vegetation, sorry, second to last question. I got ahead of myself for a moment. Start over with that. 90% of the stream bank is covered by native vegetation, including trees, understory shrubs, and non-woody plants. If there's no vegetation through disruption through grazing or mowing, and the plants are allowed to grow naturally, that would be in the optimal section. If only 70 to 90% of the stream bank is covered by native vegetation, and one of those types of plants is not well represented. So maybe there's trees, but there's no shrubs because maybe there's deer that have eaten all those shrubs, or maybe the erosion, is not letting plants grow properly, or maybe there's some mowing of grass. Then that would, be preventing the plants from growing to their natural form. So if it's 70 to 90% of the stream bank, then it would be in suboptimal. If there's 50 to 70% covered by vegetation, maybe you see patches of bare soil, and maybe mowing or grazing, then you're in the marginal category. And if less than 50% of the stream bank is covered by vegetation, there's a lot of disruption to the stream bank, then you're in the poor category. And you'll notice in this section that it also talks about native vegetation, and not everybody knows their plant identification, and that's fine. If you do know your plant identification and you observe that there's a lot of invasive species, you can subtract 1 point for each bank. So if you had on the previous slide, if you had picked that you'd picked a number for how well the stream banks are covered by vegetation, but then you notice that some of those plants or a lot of those plants are invasive species, then you would subtract. So say you had decided that you wanted to give it a number 8, but there were a lot of invasive species, then instead you would give it a 7. You just subtract that 1 point. That way we're kind of consistent. We're doing our scoring consistently. This slide shows, very well represented between trees, shrubs, and non-woody plants. They're not being grazed or cut down. So this would score very well. And both sides look good. And this one looks like a lot of the understory looks like it might be multiflora rose or something. So that would reduce the score by a point. Now, this is the last question this time. Riparian vegetation zone width. So how extensive is the vegetation on both sides of the stream? The choice for the optimal would be a riparian zone width of greater than 18 meters, where human activities have not impacted the zone. So 18 meters is only 60 feet, so you're not looking very far. Examples of human activities are parking lots, roads, lawns, a fence for animals. Is there a path? And a path, depending on how impactful you think that path might be, you could give it, you could, not penalize the stream for having a path next to it if you don't think it's impacting the stream at all. But sometimes you can tell there's a lot of foot traffic, maybe animals, like dogs going to the bathroom or something, then you might take off a little bit for that. So for example, if the width of the riparian zone is 12 to 18 meters and human activities have impacted the zone, but only minimally, then you would be in that suboptimal category. If the width of the riparian zone is 6 to 12 meters and human activities have impacted the zone a great deal, you'd be in marginal. And if the width of the riparian zone is less than 6 meters with a lot of impacts from human activities, you'd be in the poor category. So in the foreground here, we don't see any natural riparian vegetative zone. We're just seeing grass mowed down to the stream. So this one would be in the poor category, unless your stream width included part of that wooded section in the distance. And then you would take that into account. In this picture, there's a park and mowed grass on the left. On the right, there's a little more of a riparian vegetation width, but just past that, there's like a fence and a field. It might be hard to see in the photo, but so it's not ideal, but you would score the right side better than the left side. When you're done with giving all those numbers, and I forgot to say, like, you can talk over your reasoning for choosing a number with your partner or partners. This helps you, come to an agreement on the number to choose. And at the end, you add that up. And what your total is means that the habitat for that section is either optimal, suboptimal, marginal, or poor. And don't go back and change your answer. It's just like, oh, if I'd only given it one more point, it would have been optimal. You get what you get at the end. Really, it's and surprisingly, it comes out, or I felt a little surprised when I saw how consistent people could be with what habitat score they ended up with. They would, it feels like it's very subjective while you're doing it, but in the end, after you've done it a few times, you can be pretty consistent with other people doing the same method. So a few things to remember. Consider the whole 100 meters when you're answering each question. Assess the habitat after your macroinvertebrate collection. This is really helpful because as you're collecting your macroinvertebrates, you're walking the whole length, and you're very much looking at the substrate, the stream banks, the vegetation. You're getting you're taking in a lot of information that will be helpful when you're going to answer the questions. Do your habitat assessment together and bounce your ideas off one another. So I don't recommend that like one person do the macro collection and one person do the habitat, because it's really a teamwork kind of a situation. You'll get to a better result if you do it together. But don't stress too much. Like I said, really does come out pretty well once you have a little bit of experience with it. It's gonna work out. You're gonna come up with an agreement with a good score that's representative of your stretch.